All right, this is for Lily and Molly. We are finishing the last little bit of the stats formulas that we need for chapter 7, and we're on 7.3, which is variance standard deviation. Okay, we're going to start with some variables that we need. We know we need n for variance standard deviation. We know that we need, what else? S, maybe? Yeah, we knew we need S. What else? Do we use Z or T, or what do we use for variance standard deviation? The chi-squared, right? So we need to know chi-squared left. No, I put that in the wrong spot. Chi-squared left and chi-squared right. Okay? Those are the symbols that we use. And what else? I think that's it. That's it for the formula, right? Okay, and these are where you look up on the chart. So I'm going to put chart here. Do we need to label S and N, like what those guys are? Nah, we know those, right? Standard deviation, all that good stuff, okay? So let's go to the formula, and I'm going to take over. We got a big, long formula to write. Here we go. I'm going to take over this formula right here. Symbol that goes in the middle. What are we trying to estimate? Sigma. This is the population standard deviation, right? This is for population. Pop standard deviation, okay? We're just going to do standard deviation. We'll talk about variance here, but I think the ones that I have you do on the review and on the test are just standard deviation, even though we could do variance, okay? So, and this is where you're not adding and subtracting error from this, right? Okay, so formula is n minus 1 times the standard deviation squared. N minus 1, standard deviation squared. Chi-squared right goes on the left and left goes on the right, right? You remember why?
Because right's the bigger number and it'll make the whole of it smaller.
Yes, right's the bigger number, so it will make the whole thing smaller. Very good. Couldn't have said it better myself. There is the formula that we need to find the population standard deviation.
Can you try
Okay.
to say it better?
Can I try to? No. I don't even remember what we're talking about. I'm past it. I'm past it. I'm past it now. I'm thinking of the next thing. All right. Here we go. Example. Let's go to all right. Let's go to this. Let's do sorry, Indy, we used some height stuff yesterday. That's just what they decided to do.
Did you use weight?
No, sorry. Okay, so I'm going to say 17 students have height with standard deviation of, I'm going to use the same standard deviation that we used up above. Standard deviation was 0.34 feet. I don't know, which is like maybe 4 inches or something. 0.34 is a fourth of a foot, or a third of a foot. 4 inches. That's about 4 inches. So we're saying 4-inch standard deviation, or 0.34 feet is what my standard deviation is. We want to create a, what size of confidence interval do you want? 90, 95, 99? I don't think we've done a 90 yet, right? We did 95 and 99. Let's do a 90. 90% confidence interval for standard deviation of the population of all seniors at Blue Hill, okay? So it's not fair for me to definitively say that if I would sample all of the seniors, they would all have a standard deviation of 0.34. We're going to come up with a 90% confidence interval to give me a more accurate thing, okay? Good? This shouldn't be too bad. Now that we have the formula, let's label out what we have and what we need. N is how much? 17. The next thing we need is S, and that is 0.34. Then we've got to look up chi-squared left and chi-squared right, okay? How do I do that?
Look on the chart.
Look on the chart. Okay, things that we need on the chart.
Get your degrees of freedom.
Degrees of freedom. What's the degrees of freedom?
16.
16 degrees of freedom.
And look
Okay.
up the numbers.
And then go to 90%, and you should have 2 numbers. 90% is the middle one, right? That's kind of nice.
0.931
9.312, okay, is the left.
23.542.
Perfect. We're being crazy today. All right, so there's that, okay?
Friday.
All right, it is Friday. Yep,
Where's
all day, okay? All right, any questions as to where we get these numbers from? Make sure you know so that when you have to do it on the review and on the test, you know what you're doing, okay? All right, so, I don't know, did I steal a chart?
Yeah, you stole my
Did I
chart
steal
the
your
other
chart
day.
the other day? There it is.
Yeah, you stole my
Oh
chart.
man. Okay, so let's make our stuff going on here. Here's my sigma. We're trying to find these numbers, and I'm gonna do the formula, and then we're gonna call it a day. Maybe, kinda, not really. N minus 1 will be 16. Standard deviation is 0.34 squared. Okay. Now you're only squaring the 0.34. You're not also squaring the 16. Does that make sense?
Yep.
Okay. And the left one goes on the right, and the right one goes on the left. So over here, we're going to do 23.542. And the really nice thing is if you enter this into your calculator all at one shot, all you have to do is go back through and redo the bottom number, right? Okay. And 9.312 is my bottom number. So my standard deviation lives somewhere between this number, this number. Okay, these are going to be small decimals because think about what our standard deviation is right now, 0.34. So it's going to be some number on either side of 0.34.
Okay.
Got a couple of people typing this in. Yeah,
Yeah,
very cool.
trying to.
Okay,
A little bit of a struggle.
okay, that's fine.
On the left side, I got 0.28.
0.28. Yeah. Okay.
Yep.
All right, and that is in what units, by the way? If we add the units on there, these are in feet, right? Okay, so that would be 0.28 feet is like, I don't know, 3 inches maybe. Yeah, a little over 3 inches. 0.25 would be 3 inches. Okay, and what's the right number? 0.45
I got that too.
feet. Okay, all right. Let's do our little interpretation down here. So we are what?
90%.
We're 90% confident that what?
That the average or the height of 17
Let's say that the standard deviation for height
All seniors.
of all seniors,
Blue Hill seniors.
or all Blue Hill seniors, is between,
Of all Blue Hill seniors of 2022.
oh my lord, you're getting way too specific,
8 and 0.45.
and 0.45 feet. Okay, that's a lot of information. We are 90% confident that if we would survey all of the seniors at Blue Hill, the standard deviation of your heights would be between 0.28 and 0.45. Good? Are we getting better at this? Is this okay? We are getting better at this? Okay. Here's what I want to do next. On the rest of these, we did like a row right below that said N, right? How do we solve for N, or how do we find the number of people that we have to survey for a variance in standard deviation?
Chart.
Yeah, that's look up on the chart, right? If I have you do that on the test, I will give you the chart. Okay, but I'm not going to write it down here because that's just rewriting the chart. So I'll give you the chart. Excuse me, on the test, if I ask you one of those questions, I will give you the chart. But I'm not going to write it down here. So N is a thing that you could have to find. Like, how many people do I have to survey if I want an error to be this much, right? Okay, and what's the correlation between error and the number of people? If I survey lots of people,
You're gonna have a smaller.
you're going to have a smaller error. You're going to be off by a certain, like, number less, right? If I want to be lazier and survey less people, I'm going to be off by more. So my error is going to go up. So that's kind of how that works. Those are an inverse relationship between the two, okay? So we are done writing stuff down on our yellow sheet, but I want to go to the review quick. Can we go to the review? Let's go over here. Review, chapter 7, review. And let's talk through some of these examples, and I'll just do a couple of, like just overview a couple of them, just so that we're on the same page and we know, like, are we finding proportion? Are we finding mean? Are we finding variance, standard deviation? Like, what are we doing?
Never gave me a review.
I did not.
And I have this.
And you have something. Okay. If you have not turned in 7372, they're in my grade book. So if you're missing them, they're in my grade book. And you can see if I don't have it. but make sure I get them at some point. There's your degree. Okay. All right. Number 1, number 2, number 3. Let's go down to number 3. Number 1 and number 2 are asking you like starter questions. Number 1 might be a little bit difficult for you. So try to figure that out on your own. Otherwise, I can come help you. Number 2 should be pretty straightforward. This is your confidence interval, right? And they want you to find p hat. Where does p hat live in relationship to those two? In the middle. P hat is exactly in the middle. So find what p hat is. And then how do you find the error? What are you adding and subtracting to get that number, okay? And then write it in this form, whatever your numbers are, right? We've done that before, okay? Let's go to number 3. This is the first one that we have to create a 98% confidence interval. But let's see, are we doing proportion, mean, or standard deviation?
Proportion.
Proportion. Circle the word proportion. I'm going to put it off to the side. So we know that we are doing 7-1 stuff, right? So you're going to look at the 7-1 information for confidence interval, okay? Number 4. Use the given degree of confidence and sample data to construct a confidence interval for the population proportion. We're doing another proportion again. So those two are exactly the same. You're going to use 7-1 stuff, right? Okay. Number 5. Are we doing a proportion, mean, or standard deviation? Proportion. 95% confidence interval for the proportion. Okay. This just at least gives you a place to start, right? 7-1 stuff, okay? Number 6, use your own words and interpret the meaning of what you got in problem 5. That's like we are 90-something% confident, right? That's your explanation. I will ask you to do that on the test. Like, tell me what you're talking about, what this answer means. Okay, let's go down to 7. What are you doing there? Proportion again, but you're not solving for the confidence interval. You're solving for the sample size. What are you solving for? N. That's what we're solving for. So yes, this is a proportion, but you're not creating the confidence interval. You're solving for N. Do you see what we're doing here? All of these are proportions. Should we keep going and labeling these? Or do you want to try to label some on your own?
No, let's do them together.
But you're going to have to do this on your own on the test. I'll help you, but I don't care.
How long the test is?
No. I don't give you, I think the test is only 10 questions. And like 2 of them are interpret your meaning, right? I'm giving you extra
why
questions.
is there like a
You want to be
million
more
questions?
prepared on the review than you are for the test, right? How many times do you practice versus how many times you play in a game? Come on.
I never
Oh,
did practice
please, you
theory,
can't
so
shake your
that's
head
what
at
I'm
that. Come on. Number 8. What are we doing?
saying.
Oh, number 8 is not asking you for a confidence level. Which critical value is appropriate? So they're asking you what critical value you're going to use. When they say that this is unknown, what does that mean?
You're gonna use T.
You don't know your standard deviation, and
It's T.
17 is your N.
It's T.
So you're going to use the T chart, but they want you to actually find T, right? So tell me 99% N is 17. Tell me what T would be. Okay, do you want to go ahead and finish this one? This one's really short. Go to the T chart. T chart, you need degrees of freedom. How many?
16.
16 at 99%. Look it up.
2.921.
I don't know. Is that right?
Yep.
2.921. We just looked that one up, didn't we? No, it was 90% at 16. Okay, so they want to make sure that you know the difference between Z and T, right? Do you know why we're using T in this case? We don't know.
The standard deviation and it's less than 30.
And it's less than 30, exactly. That's why we use T. Okay, good, happy with that. So 8 is done. You're done with number 8, check. Okay, let's go to number 9. Use the given degree of confidence to construct a confidence interval for the population. Mean. This is a mean. This is section 7.2. And then we have to decide, are we going to use T or Z? Do you want to figure that out, or you want to try to do it on your own? Figure it out. T or Z. Okay, 20 randomly selected students. That means N is 20. Okay, so we're not yet at 30. But do we know the population standard deviation?
Yeah.
No.
Wait.
It gives me a standard deviation is 6.6. But is that for the mean or is that for the population?
For the sample.
It's for the sample. What variable do we use for that? What? Nope. Sigma is population. S. Okay, so if that's the case, what do we use? T or Z?
Z. T.
Yeah, I did.
Now you're guessing. Quick guessing. Do you use T or Z? What?
Look at the formula.
T. We use T. We're less than 30 and we don't know sigma. Okay? You figure out what T is, but then you have to do the confidence interval. So keep going. All right? Number 10, use your own words to interpret. There you go. Number 11, confidence. Construct a 95% confidence interval for the mean. We got a mean again. These are going in order, folks. Just FYI.
No way. I figured that out.
Okay?
Thanks for
I don't know. I think they might go in order, actually. I don't know. We'll see. We'll see. Okay? So, T or Z, we got to figure that out. Okay? A laboratory test of 82 chickens.
M.
There's a lot of chicken.
82 chickens. We're going to use Z. Right? 82 chickens is greater than 30. We're going to use Z. Okay? So you can get away with using Z. That's back to the first chart, that little corner in the bottom. Okay? Number 12 says use your own words to interpret the meaning, blah, blah, blah. Number 13, find the critical values of chi-squared right. And they don't ask for chi-squared left, but they just want chi-squared right that corresponds to a sample size of 19 and 99%. They're just saying, look it up and find my chi-squared right. I just want to know that you know how to look it up on the chart. And that's all.
Simple.
That's pretty simple. 14.
Make the test.
Am I going too fast? We're doing okay? Okay, let's go through. Construct a confidence interval for
What?
what? What is that symbol?
Alpha.
That's sigma, which means?
Which means
Heard
Did you
that.
hear that?
I heard that. That means what? We're a confidence interval for what? Proportion, mean, standard deviation. What are we doing? Standard deviation. This is 7-3.
I was trying to figure out.
Okay, this is 7-3 stuff. We're doing a confidence interval, so look up your 7-3 stuff. There's your thing. Okay. 15. Use your own words to interpret. Blah blah blah. 16. To find the standard deviation of the diameter of wooden dowels, the manufacturer measures 19 randomly selected dowels and then finds the standard deviation of the sample. Find the 95% confidence interval for the standard deviation. That's another 7-3 standard deviation. This is another confidence interval. Okay, this is where you look up chi-squared. That's the chi-squared chart. 17, use your own words. 18, 19 are just 18, 19, 20, 21. Those are all going to be just kind of like fill in the blank and answer the question, right? 20, why would anyone choose a 95% versus a 99% confidence interval? Isn't it better to be more confident?
Yeah.
Why would we ever choose a 95 rather than a 99?
Sample less people. With a 95.
Maybe, but let's say we're sampling the same number of people. Wouldn't we want to be 99% versus 95%?
Well, I don't know anymore.
Michelle, I am 95%
range.
confident that your grade is between a 40 and a 100. And she's like, great. You're really for sure. But 40 and 100 does nothing for me, right? Versus me saying, okay, I'm 95% sure your grade is between an 80 and a 90. And she's like, okay, that narrows it down a little bit better. So I'm less confident, but I'm more accurate. The range is smaller. I have a better idea of what's going on, right? So somehow put that into your own words for number 20, all right? Confidence, yes, we want to be more confident, but sometimes it's better to have a smaller target and be less confident, right? Okay, so put that in your own words. Think about that for number 20. All right, 21 is bonus, okay? All right, there's a lot of problems. I'm going to give you probably a couple days to work on this. Use your time. I'll answer questions as we go along, but start with the yellow sheet. Just go through. If you don't know where to start, just start filling in variables that you have, right? Okay? Which one? Number 1? Have you tried number 1?
Nah.
Okay? All right, try number 1. We'll go over number 1 here in a second
tried,
after
couldn't
everybody
do it.
looks at it. After you look at it, we'll try number 1, okay? Skip to another one, though. If you've already looked at it, skip to another one. We'll try number 1 here in a minute.
Nah. Hey, you gonna stop the video?
Goodbye, people in the video.
You're welcome.